Before that, thank you so much for everyone who is going to join us on YouTube Live as well.
Sure.
So let me share the screen. Let me know if you can see my screen.
Yes, I can.
Great. So yeah, Raj, welcome back. How are you
Hey, good
today?
evening. Good. How are you?
Yeah, we also great. We just checked the health and we just started.
Right.
Great. So thank you so much for joining on time. Okay, so let's start with the challenge 11 today. And as you know, as per the communication, what is the importance of this? Till the last session, we discussing more about how we can validate, how we can implement and validate our solutions. And at the same time, we also talk about the standardization. Now, in this week, we will talk one of the most important part, that is a control phase of the Lean Six Sigma. In that, we are going to discuss about what is the role of this phase. As the name indicates, control, that means we are going to sustain the results that we got till the last session, I can say, or till the last step of our Lean Six Sigma implementation. So just for the recap, what we had done till the last session, we identified what is the root cause of the problem. Then we identify what is a countermeasure for it. And we also seen what is the best and most optimized level for this countermeasure implementation. We talk about the level 1 to level 6. And then we also talk about the standardization and what kind of systems we can put. Now, in this phase, we can say it is going to take our sustenance journey to the next level, where we specifically talk about how we are going to sustain the results. And at the same time, we will ensure that there is a continuous improvement into it, right? So this is the control phase. It consists of 5 important elements that we are going to see today, starting with what is the approach into the control phase. This is just, I can say there is one myth about the control phase. It's not only like you're going to use the one tool and you are going to put that for the monitoring purpose and it's over. It is more than that. And what are the things that includes the control phase that we are going to discuss in very detail. Let's start with the approach in control phase. As per the similar to the whatever these stages that we had seen into the Lean Six Sigma implementation, it also has 5 important sub-steps approach into the control phase, which starts with quality control and process change management. So quality control also talks about how we are going to validate the results, revalidate it, and after that we are going to communicate the process change management to all critical stakeholders. After this communication, we also need to standardize all the processes, all documents, so that everyone will talk in the same language. Okay, so I will also show you the presentation slide, so it will give you the more clarity on that. After that, we need to establish the ongoing project monitoring as a part of it, so that we will ensure that whatever the solution that we have executed will give us a consistent results. We consistently also evaluating results, whether that implementation of the countermeasure is really meaningful or uh, going as per the plan or not. Once everything is evaluated, then we are going to hand over this entire process to the process owners, summarize the key learnings, and we will plan the draft for the future. We can call it as a moving ahead. So this is the approach that we are going to follow into the control phase. Is it clear?
Yes, sir. Yes.
Yes.
So before to go to the next element, let me show you that into the presentation mode, so that you will get the complete clarity about it. Let me know if you can see my presentation.
Yes, sir. I can see.
Okay, so this is a very important slide. Just understand this. Once you understood this slide, it will give you the clarity about what are the elements into the control phase. And after that, I will go into the more detail with each of these elements, along with practical implementation or live demonstration for our model project. Okay, so this starts with the quality control process chart, right? So we can see here, okay, it's going to be start with the qualification, validation, and revalidation that we already seen as a part of end of the improve phase. Now, once the countermeasure that we are going to implement that is validated, Then we are going for the process change management. Now, what is this process change management? This is one of the important and I can say critical step into the control phase, which talks about document the things that we are going to standardize, and we need to create a plan which will explain how to respond to the anything that is going to happen into the process. We can see here is a develop and deploy a plan for how to respond to the process change. So anything that you can see into the process that changes, how to respond to that, right? So that we are going to create. It also consists of the documentation and standardization. We also seen some part of it in the last session, where we are going to document the new process using training manuals and other tools to ensure standardization is in place. We also need to ensure the monitoring is in its place. Where we are going to use the control chart is one of the important tools that we are also going to see today. Thereby, we are going to monitor the process to ensure process stays in control and conforms to specification. Conforms to specification. That means at every single time, we are going to meet the customer specifications, right? Anything is which is going out of this, I can say the controls that is going to be controlled by this process change management, or I can say it's a control plan that we are going to discuss in detail again. Once we put the controls by using the control chart, then we need to also periodically evaluate the results by using the process capability. Like we already know as a part of measure phase, what was the before capability of the process. Now, after implementation of the countermeasure, what is the improvement into that process capability that we need to calculate. We can also calculate what is the sigma level of the process that is improved, financial results based on the improvements. And once we evaluate and we found everything is in line and as per the expectations, then we need to go for the handover process to the process owners, where hand off the improved process to the process owner for an ongoing process management and rewarding and celebrating the improvement team, right? So this is the important part. We will cover that into the challenge 12, where we are going to talk in more detail about project closure and communication, because this is again one of the most important part that we'll not cover today, that we will discuss in very detail into the next session. That's a challenge number 12. Why the project closure and communication is very important and what are the various steps into it. But just to cover that as a part of the control phase, we can see we are going to hand over process to the process owners. We are going to reward all the significant efforts during the implementation. And we are also going to document results, summarize key learnings, and identify the potential future projects. So we can say we are going to document the results, learnings, and recommendations. So next time, when we are going to take any improvement project into that particular section, it's not like that we need to start from the scratch. We already have some frame of reference which is ready, and we can take it from there to the next level, right? So this is the approach that we are going to follow into the control phase. After that, we are going to have the closure of the project. Is it clear?
Yes, sir. Yeah.
Okay, great. So this is the approach into the control phase. Now, when we are going to implement the statistical process control or control charts, it's very important that we must select the correct control chart type. Now, how we can select that control chart type? Though I'm going to explain you in very detail about the selection of the control chart based on what type of data it is and what is our intent for the control. Just to give you an overview, let's understand here. There are three main types of control chart. One is for the continuous data, other is for the attribute data, and the third one is for the time-weighted control charts. Let me quickly explain what is the difference between these three. The control chart for the continuous data are used for the data which can be expressed as integers, or I can say as a fractions, right? Let's say, for example, if we talk about the length, weight, right?
Yes.
This kind of data, right? So it's called as a continuous data. So for those, we are going to use the one set of control charts. For the attribute data, we can say it is a whole number, right? Let's say, for example, number of patients arriving to the hospital, right? Number of defects.
Yes.
So if you are having that kind of data, then we have the control charts that for the attribute data. Now, the third category is very important, which is the time-weighted control chart. This is used when your process is very sensitive, right? And you want to detect the smallest difference that is going to happen into the process, but that is not acceptable. So to detect that difference and to take the quick actions, the time-weighted control charts are going to be used. Now, let's go into the detail and understand what kind of control chart it includes. For the continuous data, there are three main control charts. The first one is individual moving range control chart, X bar R, and X bar S control chart. I will explain when we go to the example and live demonstration of this control charts. So along with their selection criteria, okay, in some time. For the attribute chart, there are mainly two types of control charts are there, P chart and U chart, though there are many variations of it is out there. So we will also discuss that. But these are the two main charts we are going to use. P chart is also called as a proportion chart, where we are going to focus on proportion defectives, where U chart talks about the number of defects per unit. So these are the two main charts we are going to see as a part of attribute charts. And in time-weighted control charts, there are three main types of control charts. The first one is moving average chart, cumulative sum chart, and exponentially weighted moving average chart. Okay, so below three charts is the part of the black belt program, and you can see the above five charts that will be included into the green belt program as well. Is it clear? Just for an overview, what are the types of control chart?
Yes, sir. Yeah.
Great. Thank you. Thank you so much. If you have any questions, please let me know. Please let me also know if I'm too fast or speed is okay.
No, you are good, sir.
Yeah, thank you. Now, the second one is, I can say this is the one of the biggest mistake I have seen that people or professionals are doing while they are going to use the statistical process control or control charts. That means selection of the Nelson rules. Now, what are these Nelson rules? Nelson rules are the rules which are explaining whether there is a presence of a special cause. And we need to only take action where there is a presence of a special cause. Now, how we can detect that? For that purpose, there are these 8 rules. Now, to understand the importance of process change, right? When we should touch the process and when we should not alter the process, there is a very important experiment that is called as a Deming funnel experiment. So in training, you can see there is a detailed simulation and demonstration of that experiment that will help you to understand what is the impact of changing the process when it is not required. Whenever it is not required to change or to make any change into the process and we make that change, actually it increases variation. It makes our process worse. To understand the importance of this process change and when to alter the process, this Deming funnel experiment is very, very important. So we will you will see that in very detail as a part of the control phase as we are going to start your learning of the control charts. Now, to understand this Nelson rules, there are 6 main types of special causes are present. Like the first one, we can say large shift. That means something is bigger change happen into the process and that you can easily notice. That is called as a larger shift. Second one is a smaller shift. So there are some rules for it. So we can detect the smaller shift into your process. The third kind of special cause is the trend. The fourth one is the over control. The fifth one is the stratification, and sixth one is a mixture. So these are the 6 main types of special causes that are present into your system or that can occur into your process. And there are some rules, thereby we can detect those presence of special causes. Is it clear up to this point?
Yes, Vijay.
Okay, great. Now, the next question comes, okay, there are these 6 types of special causes, but how we can detect them? Okay, so there are these Nelson rules. The first one, when we can see there is a larger shift. So there is a rule number 1 and rule number 5. So what the rule number 1 says? Rule number 1 says, when there is a 1 point which is more than 3 standard deviation from the mean, then there is a presence of the special cause, right? You can see that when we are going to plot the control chart, we always have the mean, and we have the upper control limit and lower control limit, which is situated plus 3 sigma and minus 3 sigma, right? So totally, we are going to focus on the 6 sigma level or 6 sigma variation that we are going to study as a part of our process, right? So whenever we see any point that is more than either plus 3 sigma or minus 3 sigma, it is an indicator of the special cause. Is it clear? Rule number 1.
Yes, sir.
Then the next one is a rule number 5, which also detects the larger shift. Look at this. This is a rule number 5. When we have 2 out of 3 points in a row are more than 2 standard deviation from the mean in the same direction, right? We can see this is a line for the 1 sigma. This is a line for the 2 sigma. And we can see in series, out of 3 points, 1, 2, 3, 2 points are more than 2 sigma level in the same direction, right? So that is an indicator of larger shift. Now, what are the situations in which we can face this larger shift? Specifically, let's say if you are going to change the operator of the machine, or the machine itself is getting changed, raw material source is getting changed, right? Or you change something setting which is very significant to the machine, right? If such a kind of things that is going to happen to your process, that means you are going to make some bigger change into your process. This kind of behavior you can definitely see into your process. That is called as a larger shift. So what are the rules we can use for it? Rule number 1 and rule number 5. Is it clear about the larger shift?
Right. So that means continuously 3 points are on one side of the process, or let's say to the upper or lower control of the limit. If it is closer to that, then that means very soon the process or the system will fail.
It is
Is it?
already failed. It is
It is already
already there.
failed.
It's already the presence of special cause. That means there is something already happening to the process, right? So we
Mhm.
can see, let's say we got this first point, then we got the second point, and then we got the third point. So 1, 2, 3. Out of these 3 points, we can see the 2 points which is beyond 2 sigma line on one direction, right? So that is an indicator of larger shift.
And if all the points are on either side of the upper or lower control limits, then
Yeah, that we'll talk about the other
okay,
things in some
sure,
lecture.
sure.
I will come to that point. Okay. So let's talk about these two rules, larger shift. Okay. So that's the rule number 1 and rule number 5. Now for the smaller shift, there are again two rules. That is a rule number 2 and rule number 6. So what is a rule number 2? Rule number 2 is 9 or more points in a row are on the same side of the mean. So we can say it's a 1, 2, 3, 4, 5, 6, 7, 8, 9. All 9 points are on the same side of the mean, right? So no point is going on the other side. So that is an indicator that something is going to be starting the process that is shifting your process on either side. We can say this is slowly shifting towards the upper control limit. That's the rule number 2. Rule number 6 is about 4 out of 5 points in a row are more than one standard deviation from the mean in the same direction. We can say this is a situation, right? So they are going for more than 1 sigma line, 1, 2, 3, 4 points. So that is an indicator of there is a presence of special cause. Now, what can be the reasons for the smaller shift? That can be the similar to the larger shift we talked, but introduction of the new raw material, new operator, that is not making so much a bigger change, but that is a change that which will be affect your process. In those situations, we can see this smaller shift. Is it clear?
Yes.
Okay. So these are the two important things we can see: larger shift and smaller shift. Another one you can see that's related to some specific processes, like we can talk about the extrusion one, where we can see this kind of control chart where 6 or more points in a row are continuously increasing or decreasing. So here we can see there is 1, 2, 3, 4, 5, 6. 6 points or more than that, it is continuously increasing. So it is called as a trend. So this is particularly, let's say, if you talk about the extrusion process, so there is some contamination that is going to be, or some impurities that is getting blocked at the filter, and because of that the pressure is going to be increased. So we can see this kind of trend. So whenever you are going to reach up to this point, we need to change the filter, right? So this kind of indicators are we can say the process controls we can use so that we can avoid the major failures into the process, right? So this is the another presence of the special cause, which is the trend. Yeah, Raj.
Yeah, you said that 6 points continuously in going in increasing trend, but still it is within the limits, and we need to identify what is making that going trend and bring it back, or
Yeah, we
just
need to investigate. So it's a indicator. It is an indicator that there is a something special causes present into the system, why it is increasing. So we need to investigate that, and we need to take the actions on it before the process is going out of control.
okay. But you see that the right after the 6th point, it came down. So what does it mean? I mean, after applying the rule 3, it came down, or
It might be we need to check what is happening to that. That's why I called it as a special cause. So we need to investigate that, right? And we need to take the actions after investigating that special cause. So it is a trigger. That means we need to investigate and we need to take some action.
right. I understand that. So can you you have any chart where the system of in the control measure system, I mean, whatever we implemented is going as per plan. So it should be like it should be that the on the mean line, or it has to be symmetry to the mean line.
I didn't get your question, Raj.
Say, you see the trend here, the 6 points are going up continuously. So something is deviating the process, or something what we implemented is occurring, may happening something to raise that one. So I want to know, if nothing is happening, whatever we implemented, it's absolutely within the spec and within the process, how the chart is going to look like.
Yeah, absolutely. So that's why these are the Nelson rules, right? So if none of these Nelson rules is present, then it is an indicator that your process is in control. I'm just talking about when your process is not in control, how we can detect that. Okay. If none of this is present, then we can say it's a good process. It's a well within control process. Okay. Once we go to the practical example for a model project, I will show you some of the control charts, so you will get a better clarity on that. So if the process is in control, how that control chart will be seen like.
Okay.
Okay, great. Thank you so much, Raj, for asking this question. Great. Now, the thing is here, like, though we have the number of Nelson rules here, we should not use all the Nelson rules. Why? Because the number of chances of the false signals are going to be increased if you are going to increase the number of Nelson rules. Now, what is a false signal? False signal is like your process is in control, still your control chart says your process is not in control. So that is called as a false signal. And if you take the action at that point of time, it is resulting into your disturbing your process. And that exactly is discussed into this Deming funnel experiment. That's why we started with the Deming funnel experiment, right? We should touch the process only when it is required. We should not touch the process when it is not required, right? And to detect that, we need to use specific Nelson rules. Let's say, for example, first time you are going to set the control limits, right? Let's say you are going to implement the control chart into your process, and that process is going to be monitored by your operators, right? So you need to fix the control chart limits, and then it will be kept for the monitoring. Let's say that's the situation. In those situations, we need to only use the rule number 1, 2, and 7, right? 1, 2, and 7. We should not use other rules because that will increase the, or I can say that will disturb the process. So there are some rules by which, in which situation, what are the Nelson rules we need to use, that is in detail cover into the training. Okay. Now let's come back to here. That's the 4 type of special cause, which is over control. This is the rule number 4, and we can exactly see here, right? So this indicates that 14 points in a row, alternating direction, increasing then decreasing, right? We can say this is 1, 2, 3, 4, 5. So in similar way, up to 14 points, we can say it's alternate up and down. So this is an indicator that your operators or process analyst or whoever is going to control your process frequently adjusting your process. This is also called as tempering to the process, right? So unnecessarily we are changing the process, and thereby this variation is getting introduced into the process. So this is also called as a special cause, over control. Then the next rule is a rule number 7, which is a stratification. Now, why it is important? When you can see this kind of trend, like 15 points in a row, are all within one standard deviation of the mean on either side of the mean. So we can see all these 14 points, 15 points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All these points are within mean plus or minus 1 sigma line, right? So this is also indicator of special cause. Now, why it is a special cause? That means something is good happen to your process, and we need to investigate that why your process is suddenly changed to this good trend, right? Might be your control limits that you said is too wide, and that might be the case. We need to review your control limits. Is it clear up to this point?
Yes.
And the last cause is the mixture. So we can see here, if you can see this kind of trend, like 8 points in a row exist with none within one standard deviation of the mean, and the points are in both directions from the mean, right? We can see, so this is the mean plus or minus 1 sigma, and we can see 1, 2, 3, 4, 5, 6, 7, 8 points. All are outside of this 1 sigma line. So that is an indicator that you're using material from different suppliers, right? Or using the different operators consistently, right? And because of that this kind of trend that you are going to see. So this is also an indicator of special cause, which is mixture. So depending on the situation, which is most critical for your process, we can select, and also the intent, we can select which special cause we need to address. And depending on that, we can select the appropriate Nielsen rules. Is it clear up to this point?
Yes, sir. Yes.
Great. Now there is one more important thing here. Now you can see the earlier it was like before few years, it was like there is only the manual or semi-automatic statistical process control which is present. But now after the evolution of Industry 4.0, machine learning and artificial intelligence, we can see almost in all the industries, the semi-automatic and automatic statistical process controls are in place. So that will monitoring your process consistently, and whenever there is a presence of special cause based on your input, they are giving some kind of trigger. Okay, so there is a presence of the special cause, and we can directly act on that, right? So depending on the situation, whether it's automatic, semi-automatic, or manual, we need to implement this statistical process control. The third point is again very important. When we go for the implementation of the statistical process control, please train your entire team, entire people on both things. The first one, how to monitor, how to check the control chart. And at the same time, if something is going to happen which is not good, or I can say which is the presence of the special cause, then what kind of actions we need to take. So that is also needs to be found out. This is going to be created with the help of control plan. We will also see one of the example for the control plan, what kind of control plan we will have for the live project, model project that we are going to demonstrate. Is it clear up to this point?
Yes, sir.
Okay,
Yep.
great. So before to go to the next important point into the control phase, which will be the change management, it's again very critical point. Before that, what we will do, let's complete this statistical process control. That's a control charts segment. Okay, let me stop the share and share with the data. Okay, so this is the data that we have collected after implementation of the countermeasure. Like we identified what are the root causes or what are the significant factors that is getting resulted into the our defects for the injection molding process. And we've seen that injection pressure, cycle time, tool wear level, and temperature, these are the significant factors. Now, we implemented the countermeasure on it, like we implement the tool wear sensors, and we also done some automation, some Pokayokes, as we clearly seen to the as a part of improve phase. So after implementation, this is the data we got. Now we need to check whether our process is in control by checking or by validating this control chart, right? So what we can do, we can just copy this entire data into the Minitab and let's see. Let me know if you can see my screen.
Sir, in the exam Minitab, they won't allow, right?
Yeah, Minitab is not allowed. So for that purpose, there is the Excel template is there. I will also show you the Excel template, okay?
Sure.
So first, let me explain this for our model project, and then I will explain about that as well. Thank you. Thank you for asking this question. Can you see my Minitab screen?
Yes, sir.
Okay.
Yes,
so,
I can.
Thank you. So before to use the control chart for this data that we have here, let me explain you the selection of the control chart first, right? So these are the main control charts, I can say, though there are the other variations of it that we will also see. So there are mainly two types of data are there, like the continuous data and attribute data, right? And as we see, what is the continuous data? Continuous data is a data that can be expressed in terms of fractions. We can clearly see as a weight, like 500.3, 499.3, and something like that. And attribute data is a data that is expressed as a whole number, like the number of broken bulbs, number of defects that we can clearly see here. So if your data is continuous data or attribute data, based on that, the multiple control charts are available. Let's talk about the continuous data. If your data is continuous, then the next factor that comes in picture, whether your data is collected in subgroup. Now, what does that mean? Let me click on that. If we are just going to collect as a one single observation, as a one data point, and we are going to use that for the control chart, then it is called as individual data point. So we can say the data is not collected in subgroup. Whereas, take an example of other case where you are going to take the measurement of 5 parts, 1, 2, 3, 4, 5. You are going to make the average of it, or you are going to calculate the standard deviation of it, and then you are going to use that for the control chart. Then we can call it as a data collected in subgroup. Is it clear?
Yes. Yes.
So depending on this, whether the data is collected in subgroup or not, if it is not, we need to use the individual moving range chart. But if the data is collected in subgroup, then we need to ask the next question, what is the subgroup size, right? If your subgroup size is 8 or less than 8, now what is subgroup size? That means how many number of parts you are going to measure, and you are going to calculate the average of them or standard deviation of it, and then you are going to use that for the control chart. If it is less than 8, let's say you have the 5 subgroup size, right? Then we need to use the X bar R control chart. And if your subgroup size is more than 8, then we need to use X bar S control chart. Now, what's the difference between these two? Why we need to use the X bar R chart and why we need to use the X bar S chart depending on the subgroup size? Can you guess based on your learning till the point? Let me give you the answer. If you have the subgroup size 8, or I can say the sample size 8, you can see here is a range. So X bar and R, that means X bar range chart, where if your subgroup size is less than 8, range is a very good estimate of the process variation. Range is a very good estimation of the process variation. That's why we are using X bar R chart. Whereas if you increase the sample size more than 8, standard deviation is a better estimate for the process variation. That's why we are going to use the X bar S chart. So instead of range, we are going to focus on the standard deviation. So this is the change in subgroup size. As we are having the more sample size, more subgroup size, we are going to use the standard deviation. Both of these, range and standard deviation, are the measure of dispersions, measures of dispersion, or we can call it as a measure of variation. So whether we should use the range or standard deviation, that is depending on the sample size. Is it clear about the continuous chart?
Yes, sir.
Great. About the attribute chart, we need to ask the one important question, like, what is your interest? Whether you are going to focus on the defective atoms or you are going to focus on the defects per unit. Now, what is defective atoms? If that part is, we are just interested whether that part is good or bad, right? Whether that part is going to pass or fail. We are not interested like how many defects that are on that part, whether there is a 1 defect, 10 defect, even there is a 1 defect, it's a defective, right? So we are not interested how many defects on that part. We're just interested whether it's a defective or not. If that is a situation, we need to use the proportion defective chart, that is a P chart. But if you're interested in defects per unit, so we can say the one part can have the multiple defects, right? So you're not interested in defectives, but you're interested in how many defects per unit, right? In that case, we need to use the U chart, right? So this is the important selection criteria. You're interested in defective atoms, we'll use the P chart, and defects per unit, you'll use the U chart. I will explain all of these control charts for our model project, so you will get a better clarity on that. Is it clear?
Yes, sir.
Okay, great. Yes. So let's come back to the example here, and we can see here, let's talk about the any one. We can take about the injection pressure, let's say, because it was the most significant factor we got. It's a number one significant factors for our project. So this is the data we got. Now we need to check whether our process is in control or not, right? So we can see here the data is collected in subgroup. We have the five subgroup size 1, 2, 3, and similar way we have the 25 subgroup size here, right? So please tell me, based on the explanation that I have given to you, which control chart I should use.
It's a R chart.
Let's talk about the injection pressure. Which control chart?
It's a standard deviation.
Standard deviation. Yeah. S chart.
Subgroup size is 5 here.
No, if you said that you are going to consider the injection pressure, right?
Yeah.
Oh, okay. Still we have a subgroup as a, yeah. Okay.
See, we are going to
it's R chart.
R chart, right? X bar R chart. Because the first thing, ask the question whether your data is continuous or attribute. Let me open this here, so you will get a better clarity on that. Okay, let's put it here, and let's focus on the injection pressure. Is the data type is attribute or continuous?
Continuous.
Continuous. Okay, let's go to the here. Is the data collected in subgroup?
Yes.
Yes. Now, what is the subgroup size? 8 or less?
Yes.
Sir, when you're saying subgroup, that means set of one. That is called one subgroup, right? I mean, subgroup. I'm looking at the C1 column. C1 column.
Yeah. So if you see the subgroup is 1, so how many points are there? What is subgroup size? You can calculate, count is 1, 2, 3, 4, 5. Then the subgroup 2 is going to be started. Can you see that? 1, right. 2, 3, 4, 5. So what is the subgroup size?
Okay, subgroup size. Okay, that is 5. Yeah.
5. So which control chart we should use?
Range. R chart.
X bar R chart, right? Yeah. So this is a chart we need to use. So let's go to X bar R chart. We can also go from there, but let me show you that here as well, because a lot of things that we are going to see. Go for the control charts and subgroup. You are going to focus on the X bar R. You can also see whenever you are going to select any option, the cursor will, if you hover the cursor over there, you will see what is the details of that, when we can use that. Like monitor the mean and variation of your process when you have the continuous data in subgroup and your subgroup size is 8 or less than 8, right? So let's select this. Now it's asked whether you have the observation are in row of columns, like we have the it's observation number 1, 2, 3, 4, 5, like that, or we have everything into the one column. So we can say yes, our all observation for a chart are in one column. So we can select this option, one column, right? Which we want to focus on. We can select the injection pressure. So we can click on this injection pressure. We can mention what is the subgroup size is a 5, right? So we can select as a 5. Once we enter this data, then we can go to the X bar R options. We can go to the test, and whatever the Nielsen rules I have told you, or we have seen sometime before, all the Nielsen rules we can see here. Like Nielsen rule number 1 was 1 point more than K standard deviation from the center line. The K is 3. So 1 point more than 3 standard deviation from the center line. So whatever exactly that I've shown you, the Nielsen rules, that is exactly implemented in the statistical softwares as well, including the SigmaXL. I will also show you in SigmaXL in some time, right? So you can click on that test and you can see there is option, perform selected test, right? So if that is the situation, like we can select which test you want to use, right? Depending on the situation. Let's say I can use only this test number 1, or yeah, that's it. Just say I just want to use the, or I can use the 2 as well. Okay. Or I can use the 5 1, right? So that we can see whether there is a larger shift in the process. I can use only the 1 and 5, let's say, for instance. Okay.
So in reality, sir, we need to remember all those rules, right? I mean,
no,
but no.
Okay. No. How many Nielsen rules we need to select? There is a guidelines for it, right? So that I've covered in very detail. If I cover that today, it will be very big session, right? Yeah. So you can go through the training and you can learn that in very detail. So depending on situation, we need to select the Nielsen rules. Okay. So let's say we select only the rule number 1 and 5 because I just want to check whether there is a large shift. That's it. Okay. Yeah. So you can click on that. Okay. Okay. So you will get the X bar R chart here, right? Now you will see the upper chart will be the X bar and below chart will be the R chart. Now the question is which chart we need to interpret first, or which chart we need to see first?
A range R chart.
R chart, absolutely. Why?
Because subgroup size is less than 8 for us.
No. Why we need to refer the R chart first or X bar chart first? Which chart we need to refer? The upper one or lower one?
The upper one.
What's the reason for it?
It will give a range basically. I mean, range can be in both the cases.
Okay, let me tell you that. So as the training is not covered, once you go to the training, you will get the better idea about it. Okay. Sure. So just for instance, we need to refer the range chart first. Why? We need to see whether your process is in control or not, right? It's a variation. If your process variation is in control, then only there is a worth, or there is a, I can say the point for looking at the X bar chart. If your R chart is not in control, just don't look at the X bar chart, because your process is not in control. We need to focus on the process first. We need to identify what are the special causes you are getting. You need to address them first, use the X bar R chart again, and then you can see, right, whether your process is in control or not. But if your R chart is in control, that we can clearly see here, then we can go for the X bar chart and we can see whether the mean is also in control or not, right? So this is the interpretation rules, interpretation guidelines when you are going to use the control chart. Now what we will do, let's change the number of Nielsen rules to all. Perform all tests for special causes. Okay, just for understanding.
Sure.
So we can click on that and click on that. Okay. Okay. Still, we will get the results which indicates our process is well within control, right? So there is, even if you are going to use the all the 8 special causes, we can say our process is still in control, right? So this is for the X bar R chart. Next, we also discuss about the other control charts. Let's say if we just have the 1%, like instead of focusing on the individual factors, let's say we are going to focus on defect percentage as individual data point, right? So we can say we are going to use the IMR chart for it. So we can go to the stat, control charts, individual, we can use the IMR chart. And here we can use the defect percentage. That's the column number C12. We'll go to the IMR options. The test, whatever you want to use, you can use it and click on OK. So still we can say the process is well within control. So that's an indicator that whatever the actions that we have implemented, whatever the countermeasures that we have implemented, that is ensuring that our process is in control. So our countermeasures are effective. The systems that we've used for the sustenance are very good, right? Let's say you are interested in U chart, right? So you want to check whether your proportion defectives is well within control or not. Then what we can do, we can just select an option for the attribute charts, and we need to use the P chart. We can select the variable as the proportion defectives as the column C8, and subgroup size is, we can call it let's say C7 sample size. P chart. Yeah, there is one change for the attribute charts. The number of Nelson rules which are available, that is only 4. 1, 2, 3, 4. The top 4. 1, 2, 3, 4. 5, 6, 7, 8 is not applicable to the attribute charts, right? So we can select what is a 1. Let's say we'll just focus on if any 1 point is beyond the 3 sigma or not. We can click on OK and we'll see. So we will see the P chart also is very beautiful, and we can say there is also the well within control, right? So in similar way, we can check, we can use the control chart. So it's not as a hard and fast rule as well. Like only you can use your specific control chart to control your process. Depending on what kind of control chart is most suitable to you, will give you the more information, more proactive actions, right? Or triggers. That control chart you can use for your processes. Is it clear?
Yes, sir.
Great.
Yes.
So thank you so much. So what we will do now, let me also show you how we can do that in Excel and SigmaXL as well. Let me share the screen. Try to open the SigmaXL here, right? That's the next important statistical software. It's a Excel add-in, as you know. It's a very effective as well. So you can see, you can click anywhere into the data. We can click on the control chart, right? Let's say you don't know for your data which control chart is best, right? So there is a control chart selection guide. So you can click on that, and you can mention what kind of data you have. So we can say whether it's a continuous data. That is also more helpful, because it is also adding the more options to it. We can say the continuous or variable data, so that you will get the clarity on that, or whether it's a discrete or attribute data. So we can say we have the continuous data. Control chart for continuous or variable data. Now subgroup size, whether you're going to collect data as an individual or subgroup. So we can say we have the subgroup, so we can select the subgroup size. Now it asks, what is your subgroup size? 2 to 9 or more than 9. So if here is small variation, it's 8 or 9. So we can use 8. That's a good one. Or you can also use the 9 one. That's good. It's on boundary. Okay, so you can.
This is something more helpful than many tabs.
So you can select subgroup size or sample size. What is it? So 2 or 9, 2 to 9, or it's more than 9. So we can say it's the 5. So we can select this option, X bar and range chart. It's very clear to us, right? So it is also have the data types and definitions. So if you don't know anything totally new to it, you can just click on this data types and definitions. You can learn those definitions. It's very powerful. Okay. Now let's select the X bar R range chart. Okay. Select on, you need to select the entire data. You can click on that. Next. Okay. And again, similar to the mini tab, you will again get the options here. whether you have the one numeric data column and subgroup size, or whether you have the two or more numerical data columns. So we can say, yes, we have one numerical data column and everything into that, right? So we can keep that selection. Then we can select where is our data? There's injection pressure. We can add it here. Subgroup size, we can add as a subgroup. Optional x-axis label, if you want, you can put it here. If you want to use the historical limits, right, that is used into the past, because let's say you are going to continuous monitoring, you can click on that. But let's say if you want to, so no data is available, you need to enter the limits here if you want to use the historical, but we can click on calculate. Please calculate limits. Test for special causes, we can click on that. Sigma zone lines. If you want to add the title and all that, that's a, I can say the other requirement settings that you can do, and click on OK. So once you click on OK, the output that will be given by the SigmaXL is more effective, more helpful, because that will explain everything about that X bar R chart, right? Is it clear up to this point? Do you have any question that is in your mind regarding the approach into the control phase and the control chart, their selection?
Yes, sir. Sir, I have a practical problem to share in this forum today. So I know I didn't inform you well in advance, but if possible, I would like to share that.
Yeah, definitely. We'll discuss that.
Sure.
Maybe let me finish this first, and then we'll take your
sure
access to share your screen and all that. Okay, so it's taking some time. So meantime, what we will do, let me share the Excel template. Can you see my Excel file that is with the control chart template?
Yes, I can see it.
Okay. So this is a template that you will get below the video of the control phase, where you can see there is the, you can directly just paste the data here, and you will get the plotted control chart, and how these control charts are plotted, formulas and everything you can see on the right hand side, right? So that's for all 5 important control charts. The IMR chart, you can just put your individual readings here, and the data is getting plotted, and these are the formulas that are used to get this control chart. This is the statistical table. You can also download the statistical tables below the video, as well as into the section of statistical tables. Right. So let me see if we can just select. Oh, it's a continue need to be changed because that's the horizontal one. Okay, but that's, we can copy that data from here, and we can paste it here, and we can again get the same control chart. One more thing, that's the control plan. Let me open that. Can you see my screen?
Yes, sir.
Okay. So as we discuss about the injection pressure and various important significant factors for our process, we can also see that what's the process step, what are the elements of the control chart. So these are the main elements, I can say, and depending on what kind of type of process you are using, what is the standard that you are going to follow, you can add the multiple columns to it, like the critical characteristics, special characteristics, and other things, right? Process number and all those. But just for understanding purpose, I just make it very lighter, right? Just to understand what is the meaning of control plan. Okay. It should mention what is your process step, what is the characteristic to control, or I can say the factor that you are going to control, what is the specification or tolerance, what is the measurement method, what is the frequency of measurement, and if you found something wrong into it, or abnormal, or there is a special presence of special cause, what is the reaction plan and who is responsible for it. So these are the bare minimum, or I can say the minimum elements that is required in any control plan. Okay. Let's say we talk about the injection pressure. The process step is injection molding. The characteristics that we want to control is injection pressure, or again, we can say it's a parameter or factor that we are going to control. What is the specification? We can say 1300 plus or minus 100 psi. So if it is 1200 to 1400, that's fine. If it is below that or more than that, then there is a problem and we need to work on it. Measurement is a pressure gauge. We need to do that every batch. And if something is going to happen which is not as per the plan or which is out of the control, then there is a need to stop the production and recalibrate the pressure setting. Now, who is going to do that? So there is a dual responsibility. Maintenance and operator has to do that together. Operator has to stop the production and maintenance guy need to recalibrate the pressure settings. If you want that more specified, you can add as a one stop production, second is recalibrate the pressure setting. And we can also separate that responsibilities for better clarity. So this is the control plan that is going to help you along with your control chart, so that if anything is going to happen into a process which is not normal, we need to take the immediate action on that. So before to go to the next point, what I will do, let me stop the live streaming. And thank you so much for everyone who attended us on the YouTube. And I'm sure this session is very helpful to you.